Hi, I'm Doug Patterson with AITech Defense Systems. For those of you who know me, you know I can be fairly out there sometimes. My presentation today is going to be different from everybody else's, whereas most everybody else's was professional and well done. So mine will be a little different. In the industry, there's been a lot of things that have been going on, a lot of changes where customers have been pushing the envelope for systems, more highly integrated systems. And always pushing for lower NRE. They're always pushing for more and higher levels of integration, and they're looking for SWaP-C. That's been around for quite a while now. Size, weight, and power, and cost. They're looking for higher levels of processing power. From the presentations you've seen here over the past couple of days, you can see where the technology and this environment and this market is going, constantly pushing the edges. But in lots of different applications, specifically UAS, unmanned airborne systems, we're seeing customers demanding a lot more power and processing and performance in smaller and lighter packages. Several platforms that you see pictured there. It's not only in unmanned airborne systems, but it's also in unmanned ground vehicles, underwater vehicles, and space vehicles. Architectures are changing. They're moving constantly, where customers find a centralized architecture works well with their sensors and effectors surrounded a main mission computer, whatever that computer is doing, whether it's vehicle management, whether it's engine control, whether it's fuel management, whether it's weight on wheels, all those different sensors, whether it's the mission computer. There's different ways to implement these systems, and all are being implemented today. So you have the distributed architecture where you have, let's say, a vehicle management system or a vehicle management computer with remote I/O modules or small systems, in some cases ARM-based, that are doing data concentration and data I/O, and then concentrating those and then dropping those onto a dual redundant network, whether it's either 1553 or Ethernet. So all of these systems are now allowing our customers to push the envelope in the way that they're integrating systems. If you look at a typical avionics systems, they always had the vehicle management computer, which controlled the flaps, which controlled the flight, which controlled the autopilot, what have you. That was a separate computer system. And then the vehicle mission computer, which drove the heads-up displays, the system displays, the cockpit, that was also a separate computer. What we're seeing now is where customers are seeing a lot of this power and performance, what they're getting from today's multi-core processors, they're moving all of these architectures back into the same box. So some customers, I would have said, you know, a couple years ago for the people I've talked to, oh, distributed's the way to go because you're moving all that intelligence out to the sensor. And that's what they were doing. But now that they're seeing the power and performance from the technologies that are out there today and the amount of memory they can get and the flash memory and the DRAM memory they can get and just the quantities and the sizes, they're packing those functionality back into a single system and getting the economies of scale associated with reducing their hardware, and the MTBFs go up. Some of you might recognize the guy down there in the lower corner. There's lots of different platforms that are out there. John Keller's done presentations on UUVs just recently in a blog. They're remotely piloted vehicles and they're fully autonomous. I knew I'd mess that up. Fully autonomous vehicles. Good example of that is Predator. That's where somebody sits in someplace in Nevada and actually pilots the aircraft all by from wherever it is in the world. That is an aircraft that is extremely susceptible to intervention or hacking or whatever you want to call it. And that is a threat. And then you have fully autonomous vehicles like the RQ-4 Global Hawk, where the main mission is programmed into the unit and off it goes for some 24, 26, whatever it is, hours, and sits there and loiters up at around 70 some odd thousand feet, does its mission, and then comes back all by itself. Nobody tells it to do a thing. It does it all by itself. So those are fairly less prone to intervention. We're seeing applications for unmanned systems and optionally piloted aircraft, which is optionally manned systems. Took me a while to wrap my head around that, where the customer's coming up with a UAV platform, but he had to have 2 pilots in it from time to time. So it's a typical aircraft with all of the controls and all the displays, and also a computer that ran the entire mission. by itself so that somebody could sit there and watch it and maintain it and control it if needed. So the list is endless on the number of unmanned systems that are out there. We're seeing helicopters, we're seeing hypervelocity missile systems that are being put together. This is where they're taking COTS hardware, starting their system design, and then moving it with our help and assistance to put it into a custom form factor. So they're taking a 10 by 12 maybe box that's maybe about 1.5 inches thick, and then migrating that down to a 5 by 5 box with all the functionality that they needed, specific for the aircraft. So this gets rid of some of the issues of starting with COTS, getting what they want, starting with the military hardware, and then migrating it to the exact form factor they need. DARPA and the U.S. and the Navy are currently today experimenting with multiple controlled synchronized UAS. Sounds like an old movie that we used to see where you had one aircraft controlling multiple drones. Well, that's exactly what we have today, one aircraft controlling multiple drones. This is expanding the C4ISR network to much greater extents, extending the aperture of being able to collect data over a much wider area. Not only is this good for interdiction issues and for combatant issues, it's also great for certain search and rescue, and that's where it's being really concentrated on now. You all know about the 2 helicopters that crashed over Hawaii. This is a great application for technology like this. But using multiple sensors and then combining the data after, that's been around for years and years and years. Radio astronomy's been doing that for years. Wireless. Wireless is great until you've got some really secure and sensitive data on it that you don't want anybody to have, or you're using it to control your platform where somebody else could either jam the signal or actually interdict the signal and take it over. There have been, not very widely known, but maybe some of you know, there is a website, I put the website at the bottom, of about the drone crash database. There are about 100 or so drones that some US, Turkish, Israeli, Russian drones that have crashed. Some are kind of interesting. I think there was one in San Diego that actually a Predator crashed in somebody's backyard and took out the swing set. But thank God it was just the swing set. But there are several issues that we know of where Iran took over one of the RQ-170 Sentinel UAVs and took it over and brought it down into enemy territory. So that exists. So the issue of cyber warfare, it's real and a present danger, it's there. And putting that into the unmanned systems is now paramount. And we're seeing that from our customers for trusted platforms, trusted boot. You heard from the NXP guy yesterday, Matt, talking about how their platforms are supporting that. Customers are asking for that, and they're asking for the hardware platform to support the trusted boot and the trusted architecture, and they're embedding encryption right into the system. So a lot of different ways that you can encrypt data as well as supply the key just upon takeoff or on deployment of the vehicle, and then that system is stores that memory, stores that key, in volatile memory, so that if the power is changed or that gets a scram signal, that the UAV can actually go stupid. And a lot of the flash devices now are supporting secure erase to allow the customer to wipe the flash, and the flash then automatically takes over and not only clears itself, but also writes itself several hundred times to actually wipe the data out. So we're seeing those kinds of systems kind of sneak into what's needed, but that the multiple levels of security software has to be implemented in hardware at the root level, or else it's just a layered application that can be just wiped out very cleanly and easily by somebody who really wants to get at the system. So data encryption, it's coming. We're getting asked for it every single time that we talk to a customer that has this kind of platform, whether it's UUV or UAS or UGV. So integrated multiple levels of security in the hardware and layered some layers of security on top of that to support the initial hardware. But if it's not in hardware, all you have is an application that can be stripped off in software. Boy, look at what's going on in the commercial industry today with drones. I mean, I've got one at home. I got it for Christmas, for Christ's sake. We gave it away to kids, for the kids to play with. These are so intelligent with stabilized gyros inside. You take your hands off the controls and it just sits there and waits for you to tell it to do something. It's amazing, and this thing sits in the palm of my hand. It's built with graphite and graphene and composite materials, so you can crash it into the wall. My kid takes over, it smashes it in, chases the dog down the hall, which shouldn't do. But he does anyway. And off it goes. And this thing is just absolutely amazing. It's one of the most fun toys I wish I had when I was a kid. I think Jerry said last night, the things that the kids have to play with. These drones are getting even smarter and smarter. In other words, if you should take the hands off the controls, or if the control signal should be lost, the drone comes back to where it was launched from, all by itself. You didn't tell it to do anything, and it just lands in front of you. It's absolutely amazing, the things that are going on today. But you can see, I don't know if the bottom left picture there, that is a tiny, small helicopter drone that Special Forces are using to go and check out a structure, to go and look around inside first. You've always seen the drones that looks like the hummingbird. It's absolutely amazing. It looks like a hummingbird and flies around. It's a fully HD camera. So with the proliferation of cell phones and smartphones, everybody knows what's inside. You've got ARM processors in there, multi-core. All of the sensors that are in there, you may not be aware of what's in there, but it's not just GPS. But you've got accelerometers in there. You've got magnetometers to power your compass. It's got MEMS gyros in there. If you go to Crossbow on the internet and get this thing called X sensor, it brings up about 3 separate different applications that shows you acceleration, it shows you GPS, and it shows you basically all of the sensors that are inside the phone. It's absolutely fascinating. If you haven't tried it, you give it a shot. It's worth the time. So advanced processors and technologies are driving into defense. I'm amazed and I marvel at the applications the customers keep coming up with for these technologies. And the platforms that we, as this industry, provide is COTS platform, platforms for customers to, I mean, you just heard it, right, from 4DSP and Sensoron, where they were able to start, they were able to get to market quicker, they were able to reduce their NRE, they were able to do a proof of concept. That's what this whole industry is about. And this kind of technology breaking into many new defense applications is just mind-boggling. I remember, just a few years ago, sitting in front of the IEEE, talking to the guys who were running the VDIC Technical Committee, and Lime, and Shlomo Patel, and Wayne Fisher, and doing a presentation on what was next in coming, which is this concept called military conduction cooled VME. And they all looked at me and said, nah, never work, never gonna happen. So, okay. So things have moved on since then. You bring the technology to the customer, he's gonna use it. So you've got advanced Intel architectures, the Core i7, boy, that is just a kick-butt device. I want to apologize ahead of time if there are any spurious audio emissions during my presentation. It was something I ate last night, so I apologize ahead of time. We heard about spurious emissions yesterday. Okay, so lots of processors out there, the multi-core ARM processor from Freescale, from Intel. You've got the Freescale. One of the questions I was dying for somebody to ask Matt yesterday and saying, what the hell happened to AITech? What did you guys do? Why did you do that? And that's still an answer I don't have back. But AITech is back now. If you look at their latest generation of T-series device, each core has its own AITech vector processor tied to it. So in the 4240, for example, you've got 12 AITechs tied to each core, which imagine the power that brings to applications now. And yes, when Freescale kind of stepped on themselves and when they got rid of the AITech, and a lot of people switched to Intel, but not everybody switched to Intel. A lot of our customers are asking us, when are you coming out with the next generation Core IQ device? Because they need the vector register, the 128-bit vector register, to do the work they want. So that series of processors is making a nice comeback. Not everybody switched to Intel or ARM. The RTOSes, look at the tools. I mean, if you look at today's technology and you compare it to, what, a few thousand years ago, and then a few hundred years ago, and then a decade ago, you look at the advances in the tools the tools are what allow us to do the things that we do today. James Burke did a book back in the 1970s, I believe, called Connections. And if you haven't read it, I really recommend it. It is fascinating. He takes the connections from the development of the stirrup to the atom bomb. Now, kind of a stretch to figure out how that happens. It's very entertaining. You may disagree with him vehemently in a few places. In any case, it's quite entertaining. Also, PBS did a series with James Burke called Connections. Again, fascinating. You can catch it on Netflix. So the RTOSs and the development tools have advanced so quickly now that are allowing the customer to work with these advanced processors and the trusted boot platforms and all of the technology that surrounds it to be able to build really kick-butt systems. I mean, just unbelievable. In one application that we were involved in, we have an off-the-shelf COTS, no NRE, two-slot VPX, Core i7-based processor system. Okay, great, wonderful. We brought it to the customer and said, here, as a loaner system, and said, here, try your software. He developed all of his software, 8 individual applications on a laptop. And that's how he developed his system, and that's how he put it in the lab. And then he was working towards deployment. So we gave him a system and said, here, try it out. A week later, he calls us up, and I'm going, a week? Oh, God, I know what that means. So I got on the phone, called him back, and the customer said, just wanted to thank you. Really? Why? Because everything that I had ran exactly as I needed, and I had 50% performance of the CPUs in reserve. So everything worked exactly as he wanted, and he had the full mil-spec platform and full mil-spec box that dropped right into his aircraft in a small half ATR short chassis. The customer was thrilled. So those things happen not often, but it's nice when it does happen. And we save the customer time, money, and a lot of aggravation in getting to where he needed to go. So those things are happening, and each one of you out here, I'm sure, has a success story like that. It's not unique to anybody. So we've got all the development tools, we've got advances going on in there, which allows the customer to be freed from trying to worry about USB stacks or TCP/IP stacks and all of that headache associated with what once was the embedded market. He now is focusing on his application and bringing those applications to market with a whole bunch of different types of platforms and processing. So there are modular flexible I/O systems. The one I was talking about just now for the UAS is down the lower right. There are all of these systems that are available essentially with no NRE. A lot of these applications, a lot of environments where the customer is saying, look, I need to get to something quickly, I have to deploy it quickly, I have a demo to do, what have you. So each one of these boxes has the ability to have a processor inside, wireless if needed, and connections and remote I/O to allow you to build very sophisticated platforms and systems today with no NRE.